Hello everybody, welcome to chapter 7.3 part 1, the Pythagorean Theorem. Most of you may have heard of the Pythagorean Theorem. It is probably one of the most famous relationships in all of mathematics. And it states that in a right triangle, the sum of the squares of the length of the legs equals the square of the length of the hypotenuse. Now this was mentioned earlier when we were talking about the square root of 2, where essentially we called A1 and B1, which would be called the two legs. A and B is usually referred to as the two legs. And then C is the hypotenuse. When we were talking about irrational numbers, the square root of 2, we used the Pythagorean theorem. And as mentioned, the two sides that come together to form the right triangle are called legs. The lengths of the legs often are A and B, and then we have the side across from the right angle, where this is a right angle, is called the hypotenuse. And there is a hypotenuse falling into place. And this little square here means that it's a right angle. And we often call the hypotenuse C. So, again, the Pythagorean theorem says that given a right triangle, that's what, when it has a right angle, we call it a right triangle, with legs A and B and hypotenuse C, A squared plus B squared, meaning the lengths of these sides, is equal to C squared, the length of the hypotenuse. So now we're going to look at example 1. So we're going to find the value of x, and we're going to give the answer in the simplest radical form that we can. So we're going to use here, to do this, we'll use the Pythagorean theorem. And as we said, a squared plus b squared is equal to c squared is the Pythagorean theorem. And then we substitute 2 for a and 6 for b and x for c, because we don't know what the hypotenuse is. So there we do it. We find 2 squared is 4, and 6 squared is 36. We have 40x squared, and in order to get rid of the x squared, remember the rule, we'll take the square root of this, and that will give us x alone, and then we'll take the square root of 40, so we can find that the square root of 40 is equal to x. And then, of course, we're going to simplify this, so we're going to look for the hidden perfect square, and in this case it's 4, so there we get x is equal to the square root of 4 times 10, and we can pull out the 4 as a 2, and there we have our final answer. So here we have example 2, which is a little more complicated, because we have, not only do we have x, but we have x minus 1 as one of the sides. So we're going to actually go about that and just substitute in as though this is just another a or b, another leg. So here's what we do. We have our Pythagorean theorem, and we substitute in x minus 2 for a, and 4 for b, and then just plain old x for c. So here, look, we have this, and then we have here, and now we want to solve that. So we multiply, and we find that we get x squared minus 4x plus 4 for this when we expand this. And then, of course, 4x is 16, and that's equal to x squared, because cx squared. But it turns out that these two x squareds cancel out, because if I bring this one over here or this one over there, they cancel out when we combine the terms. So we're just left with negative 4x from here, and then 4 plus 16 is 20, and then we did negative x squared plus x squared, and so they cancel out, and then we end up solving for x, and there we get x is equal to 5. And here again, here example 3 is similar to example number 1, where we just want to find the value of x given two numbers. Each leg is identified with a number. And here again we use the Pythagorean theorem. We substitute in 4, let's say 4 for A and 8 for B. And you can reverse it. You can say 4 is B and 8 is A. It doesn't really matter, but we'll do it this way. So we have 4 squared plus 8 squared is equal to x squared. And there we simplify, take the square root of both sides, and now we look for the hidden perfect square, and in this case the hidden perfect square is 16, so we can pull out the 16 as 4, and we get 4 square root of 5. In example number 4, again we want to find the value of x, but here we have x plus 1 is the hypotenuse. Now remember, we know that the hypotenuse is what's across from the box here. That means the right angle. So this is going to be the biggest, and these two are the legs. So when we substitute it in, we have x for A, 12 for B, and x plus 4 for C. So we want to solve for x so that we can figure out whether what this side is and this side is. So here we do it, and then of course we want to expand this. So we end up getting multiply. So here x squared and 12 squared is 144, and then if we do x plus 4 times x plus 4, we get x squared plus 8x plus 16, and now we want to combine in order to solve for x. Well, it turns out these x squareds are going to cancel out. We're left with 144 is equal to 8x plus 16, so we bring the 16 over and get 128 plus 8 is equal to 8x, and then of course we divide by 8x and we get x is equal to 16. So to finish it up, we now know what the leg is, so our leg here is 16, and then our hypotenuse here, if we add in x plus 16 plus 4, that means that that is 20. In example number 5, we have a similar situation. Here's our C, here's let's say A, let's say B, and then here is C squared, and then I expanded it out here, and here is B squared, x squared, and A squared, 9 squared, and then I just proceed to solve that, where x squared plus 81, where 9 squared is 81, and then this implies, so I take this one, and that's equal to, which I had expanded here, and this is x squared plus 6x plus 9 is equal to x squared plus 89. As you see, the x's, x squareds will cancel out, so it makes solving it a lot easier, like before. So we have 6x plus 9 is equal to 81, and therefore x is equal to 12. So if we put back here, this leg will be 12, and this is going to be, this leg is 12 plus 3, or 15. Let's look at an application of Pythagorean theorem. So we're going to look at a situation with a ladder leaning against a wall. So we're going to let x be the distance in feet from the foot of the ladder to the base of the wall, and that would be B in our picture here. And then we're going to let 4x be the distance in feet from the top of the ladder to the base of the wall, and that will be A in our picture. Now we're given that the ladder is 30 feet long. So here's the ladder itself is 30 feet long. So we want to figure out what is the distance of the ladder from the wall B, and we want to round that to the nearest foot. So let's look at that. Well, of course, we're going to start out with the Pythagorean theorem, and the Pythagorean theorem, as we have already stated, is a squared plus b squared equals c squared, where these two are the two shorter sides and c is the long side, and in this case is the length of our ladder. So now we're going to plug in the appropriate parts. So we're going to substitute in 4x for A, x for B, and 30 for C, because that's the length of our ladder. So there we do that, and now we solve that. So we multiply and combine like terms. So we end up with 16x squared plus x gives us 17x squared, and 30 squared gives us 900. And now we continue on, and we have x squared is 900 over 17. We take the square root of both sides, and that tells us, after we plug these things into our calculator, it tells us that our ladder is approximately 7.8 inches long, but since we're told to round it to the nearest foot, that means it's approximately 7 feet. So the distance in feet from the base of the wall to the ladder is about 7 feet. Thank you very much. I hope that you enjoyed this video. Be well, take care, and goodbye for now.